Alright, so we're going to look at story problems today using law of sines and law of cosines. On a lot of these we will have to set up the pictures, so that will be the first thing we'll do. So let's look at number 1, read it through. Fire towers A and B are located 10 miles apart. I'm just going to draw that. I'm going to draw a point for fire tower A, a point for fire tower B. You could be more artistic with that and actually draw towers, but all we need to know right now is that they are 10 miles apart. They use the direction of the other tower as 0. So if I'm looking from A to B, that's 0 degrees. Rangers at fire tower A spot a fire at 42 degrees, and rangers at fire tower B spot the same fire at 64 degrees. How far from tower A is the fire to the nearest tenth of a mile? So they're using the other tower as 0, so A is looking out this way, and so my angle is going to be with respect to B. So we're going to draw, the fire is out here somewhere. We'll make flames. There we go. Something's on fire. And so this angle they're saying is 42 degrees from tower A. From tower B to the fire, it's 64 degrees. And this is something that could actually happen. If you've got the two towers calling each other, they would get the data together and figure out just how far out there it is and where it would be on the map and all of that good stuff. So it says, how far from tower A is the fire to the nearest tenth of a mile? So they're trying to find this side over here. Since we've got this called A and that called B, I'm going to call this side little b, because it's across from what angle B where tower B was. So what we want to do first is see if you can set up the law of sines. We could if we knew what this angle was to go with 10. So let's find this angle really quick. So we're going to add up 42 and 64 angles we have so far. That's 106. Triangles add up to 180. So take 180 minus 106 and you get 74 degrees. So over here is 74 degrees. That is across from the 10. And then I want to know B, which is across from the 64. And we could use law of sines since we have angles and sides across from each other to figure out this distance. If we can avoid law of cosines, we do. So law of sines, we just set up the proportion. So sine of 74 degrees over 10 equals sine of 64 degrees over B, and we just solve it. And there's no looking for a second triangle or anything like that because we're solving for a side. We only have that ambiguous situation if you're solving for angles. So we cross multiply 10 times sine of 64 degrees equals sine of 74 degrees times B. So we want to solve for B and figure out what that is. How do we get B by itself? Divide by sine of 74 degrees. That cancels this out. Divide this by sine of 74 degrees. And now we could just put this into your calculator and it comes out to be about 9.4 miles. So that's how far it is over here from tower A to the fire. So if you can set it up and have an angle with, if you have one pair of angles with sides, angle and side pair, you can use law of sines to find the other stuff. Okay, so the next one actually has a picture, which is nice. It says, find the height of the building in the figure below to the nearest foot. We actually have a triangle over here that's oblique, not a right triangle, and then we have a triangle over here that is a right triangle. So ultimately, what we're trying to figure out is this height. Actually, the right triangle would kind of go to the middle of the building, if you want to envision that. So this is the height that we're looking for over here. But I don't have enough information with just the 48 and the right angle to go straight into that because I don't have any sides on this triangle. That's where this triangle over here will come in. So if I can find this side right here that the two triangles share, then I can use that to solve for this. So when you have two triangles together, generally speaking, you're going to want to find the side where they sort of meet first. So I'm going to call this side X. So I know that this is 150 degrees. I have 35 over here that goes with X. And then the 150 I need to figure out goes at this angle. I can't do that directly, but I could find this angle over here. How do I know what this angle is?
180
So 180 minus 48. These two together make a straight angle, make a 180. So if I take 180 minus 48, I get 132. I almost said 42. So this is 132 degrees. So they expect that you guys know that two angles next to each other that make a straight line add up to 180. And then I can use this and this to find this angle up here. So it's like a giant puzzle. So we're going to add 35 and 132 together to get 167. And then if I subtract that from 180, I get 13 degrees for this skinny little angle up here. I needed that 13 to go with the 150, and the 35 can go with the x, and I can use law of sines. So sine of 13 degrees over 150 equals sine of 35 degrees over x, which is this side over here. And we can solve that just the way we did the last one. So 150 times sine of 35 degrees equals x times sine of 13 degrees. And just like we did the last one, we can divide by the sine of 13 degrees to get x by itself. And all of this can go into the calculator, and I get 382.467. I just kind of kept a lot of decimals because this is an in-between step. I could probably round that off to 0.5. I'll do it. I'm feeling rebellious. Let's just round that off to 0.5. It's still a lot of significant digits compared to what they gave us, but I always hesitate to round it off till the end. So that means this over here is 382.5. We got it off of this oblique triangle, but then that would be the hypotenuse of our right triangle. So now we could solve for the height using the 48 degrees. So opposite 48 degrees is the height of the building that we want. Hypotenuse is over here, so if I'm using opposite and hypotenuse, that would be sine from SOHCAHTOA. So we could set up just a simple trig ratio. Sine of 48 degrees equals the height over 382.5. Going back to just some regular trig, multiply both sides. I'm going to write it out again, just so I put the decimal in the wrong place though, trying to go too fast. Multiply both sides by 382.5 to get that out of the denominator. And if I do that, I get 284.2. In the directions, it says to find the height of the building to the nearest foot. So my final answer is just going to be 284 feet. And that's it. So it's like a giant jigsaw puzzle. You have to solve for what you can and then keep going. So those both, we could use law of sines, and then we use some basic trig to do the right triangle. Basic trig is always the easiest. Law of sines is sort of next in line. And then sometimes we have to use law of cosines, which we'll see on the next page. So let's look at number 3. Mary is orienteering across a large flat plane from marker A to marker B, which are 4 miles apart. I think this means that she's like hiking with a compass. I'm not entirely sure what orienteering is, but that sounds right. It's like she's out using, so she's going across, we don't really know like how this goes. So I'm going to say A's here and B's there. I'm going to draw sort of a random segment between A and B, and they tell us that it is 4 miles apart. After walking 1.8 miles, she realizes she is 6 degrees off course. So let's say she's walking, she actually walked this way, and she's off by 6 degrees. I drew it bigger than 6 degrees, but it's not a big deal. To the nearest tenth of a mile, how far from marker B is she when she realizes her error? So this is where she's at when she went in 1.8 miles, but she wants to get back over here. So she's trying to figure out what this distance is. So since this is across from what we have as big A, I'm going to call this little a. I do not have the side across from this angle. I don't have any other angles. We cannot use law of sines because we can't set up the proportion. We do have a side angle side situation. I'm going to just put that on there, which is one of the situations that we use law of cosines for, because you basically just have to. So we're going to use the A version of the formula. I'm going to write the formula out just to make sure we all know what it is. So A squared equals B squared plus C squared minus 2BC cosine of angle A. So that's the version that we're using, and then we're just going to put in the 4 and the 6 and the 1.8. So A squared equals 1.8 squared plus 4 squared minus 2 times 1.8 times 4 times cosine of 6 degrees. And you, in theory, can type all of that straight into a calculator, and it comes out 4.91888, blah, 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 keeps going. And then you can square root that. So I'm going to write it again and put a square root on it to show that we're solving for A. And it says they want to the nearest tenth of a mile, how far she is off, so I rounded the final answer off to 2.2 miles. So that was actually pretty straightforward once you get the picture set up. Setting up the picture is the worst part of this. Once you get the picture set up correctly, after that it shouldn't be too bad. Okay, so our last story problem. Peter has 3 sticks measuring 19 inches, 23 inches, and 27 inches. He lays them down to form a triangle. Find the measure of the angle enclosed by the 19 and 24 inch sides to the nearest degree. I think this is a dumb story problem, but there are real life applications where you could have a similar situation, so we'll just go ahead and set it up. So pretend this is like some real life application where we're looking at distances on a map or something. So we know we have 19 inches, 23 inches, and 27 inches for our triangle. They're not all the same. It's a scaling triangle. And it wants us to find the measure of the angle enclosed by the 19 inch and 23 inch sides. So that is this angle over here that we could call theta, or we could call it whatever we want. Let's call it angle, we want this angle, we'll call it angle A. Doesn't really matter. So then when we're setting up our law of cosines, we could use that same formula we had before. A squared equals B squared plus C squared minus 2BC cosine of angle A. Because I called it angle A, it just kind of works. So, and you have to solve when you're doing these for the largest angle first, but we lucked out. This would be the largest angle because it's across from the longest side, so we don't have to worry about doing anything else first. So A squared equals 19 squared. Oh, so I ought to set this up. This is side A, and these would be B and C, the 2 sides that are on the side of the angle. And A would be 27, so we're putting that number in. I'll get there eventually. So 27 squared equals 19 squared plus 23 squared minus 2 times 19 times 23 cosine of angle A, which is what we're actually looking for, so we're going to leave that as A. So we can do 27 squared, we get 729. We're going to do the 19 and 23 squared, square them, and then add them. If you just put that part in, you will get 890. And then we do all of this together, so 2 times 19 times 23, and you get 874 cosine angle A. What do we do next?
Minus 890.
Subtract the 890 so that we can get the part with that cosine by itself. So if we subtract that, we get negative 161 equals negative 874 cosine of A. Then what?
Times by 1 over negative 874.
Or just divide by negative 874, which would be the same thing.
Right.
You can multiply by the reciprocal, it's the same thing. And then you will get this weird decimal 0.184 blah blah blah. So how do we actually get the angle?
Cosine negative 1.
Yes, so that's called inverse cosine. So you'll put in that number, whatever it is, from your calculator, and that'll give us A. It comes out about 79.38, blah, blah, blah. It says they want us to find the measure to the nearest degree, so we'll just round that off to 79 degrees for the final answer.